Hi children, in this video is about how the resistance of a system of resistors. We know how the current and resistance and potential difference across a conductor. The relation connecting these three: current, potential difference and resistance of a conductor. Here in so many appliances or gadgets, we use different values of resistance. So we want to use a combination of resistances in such cases. Here we are going to discuss about how we can use Ohm's law to calculate resistance when they combine. When the resistors are combined, how is its resistance that we want to find out by using Ohm's law. See, we can connect resistors in two different ways. One is in series. One method is in series. That means suppose three resistors R1, R2 and R3. These three resistors connected the end of first resistor to the second and second to third one in this manner. When the three resistors are connected in this manner, that means R1, R2 and R3 are three resistors connected in series. We want to find out its effective resistance or equivalent resistance. We want to find out the equivalent resistance when they are connected in series. See, these three resistors connected in series and an voltmeter is connected. An voltmeter is connected parallel to these resistors. This voltmeter is connected parallel to R1, R2 and R3. Later, the potential shown by it when they connected in series. Let V be the potential shown by these resistors. That means potential across these X and Y. That shows V. See the current I reaching here. That means the current through R1, R2 and R3 the same. That we can find out separately. Suppose we connected, this is R1 and the potential across this we measured by using voltmeter, and to measure current we connected ammeter in series. Now the current is shown by this R1 is same as I. So current through this one is I, but potential difference across this R1 is V1. Similarly, we can find out potential across R2 and by connecting an voltmeter parallel to it and ammeter in series. Here also current is shown by it I, but the potential shown by it is V2. So potential across R1, R2 and R3 will be different. Here the potential difference is different, but the current through this all will be the same. Let V be the potential across this X and Y. So current through these resistors R1, R2 and R3 is I. By Ohm's law, we know what is V is equal to IR. And similarly, potential across R1 is V1 and that is equal to IR1. And similarly, V2 is equal to IR2 and V3 is equal to IR3. But the potential V is equal to what? V1 plus V2 plus V3. Potential V is equal to V1 plus V2 plus V3. That will be measured by using voltmeter across connecting X, Y, we got V, and across R1 we got as V1, similarly V2 and V3. Putting these values here, that means V is equal to IR that means I into R. R is the equivalent resistance of these three resistors. So they are connected in series, so that we can write as IRS. S4 series, that is similarly V1 is equal to IR1 plus V2 is equal to IR2 and V3 is equal to IR3. That means again IRS equal to I is taken common, then R1 plus R2 plus R3. We can cancel I from both sides. What will get? That means equivalent resistance. Equivalent resistance Rs equal to R1 plus R2 plus R3. That means equivalent resistance is the sum of the resistance of the resistors. Let 2 ohm, 3 ohm and 5 ohm, they are connected in series. Now the equivalent resistance Rs is equal to 2 plus 3 plus 5, that is equal to 10 ohm. That means effective resistance now in the circuit is much more than the individual resistance. Now the resistors, second method, we are going to connect resistors in parallel. Now we are going to connect resistors in parallel and its equivalent resistance. Let R1, R2, R3. 3 resistors of resistance. Here 3 resistors of resistance R1, R2 and R3 connected between the say between 2 points, so they are parallel. That means from the common points they are connected. And to measure potential across this one, we connect an voltmeter. We connected an voltmeter. Now see, current through the circuit, that means current through the circuit that we can measure by using ammeter. So I be the current that's shown by the ammeter now when they are connected, when the resistors are connected in parallel, and the total current through the circuit, let it be I. Now we want to find out potential across each resistor and also current through it. Let first resistor R1 of resistance R1, we connected a voltmeter parallel to it to measure potential difference and current through it by connecting ammeter in series. That means in this way when we connect, we got potential. That means potential here shown V, that is same as the potential we got when they are connected between the points X and Y. So here potential V the same, but current through this R1 is now the current through R1 is I1. Similarly, we can find out potential across R2 by connecting an voltmeter parallel to it and to measure current connect an ammeter in series. The potential now it also shown by this R2 is V. R2 the potential we got from the voltmeter is V, but current through the resistor R2 is I2. Similarly, when we measure potential across R3, the same potential we will be get, but the current through it this is I3 when we measure current across this R3. Now see, total current through the circuit, that is I, that current I is equal to I1 plus I2 plus I3. What is I1? I1 is the current through R1, and what is I2? It is the current through R2, and I3 is the current through R3. And that current I is the total current now through the circuit, but the potential will be the same in all the resistors. Potential when we measure across R1, R2, R3, and the combination also will be the same. We using Ohm's law, we know what is current I is equal to V by R. Let R be the equivalent resistance of these three resistors. So I is equal to V by R. We can put here P for parallel connections. Similarly, I1 is equal to V by R1 and I2 is equal to V by R2 and I3 is equal to V by R3. Putting these values in this relation, so what will get I? Instead of I we can write V by Rp and is equal to I1 is equal to V by R1, similarly V by R2 and V by R3. And see here we can take, that means V by Rp is equal to, we can take V common, so V into 1 by R1 plus 1 by R2 plus 1 by R3. Now we can cancel V from both sides, then what will get 1 by Rp, that means reciprocal of the equivalent resistance. Reciprocal of the equivalent resistance is equal to the reciprocal of the first one plus reciprocal of the second one plus reciprocal of the third one. So when the resistors are connected in parallel, its effective or equivalent resistance Rp, that is its reciprocal is equal to the reciprocal of the individual resistors. That means 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If the three resistors, suppose as shown below, 2 ohm, 3 ohm and 5 ohm are connected, then the equivalent resistance 1 by Rp is equal to 1 by 2 plus 1 by 3 plus 1 by 5. 1 by 5. This equivalent resistance Rp is smaller than, that is Rp is smaller than this 2 ohm. That means when the number of resistors are connected in parallel, equivalent resistance in the circuit is smaller than the smallest resistance connected in the circuit. Smaller than the smallest resistance in the circuit. Now, another thing you want to remember, we can connect appliance in the circuit in two different ways. One is in series. One method is in series. Suppose an electric bulb and an electric heater, we are going connected in series. If they connected in series, what is the problem? Current through these two will be the same. So electric bulb and electric heater, their current required is entirely different. So we cannot connect them in series because they cannot work its proper power. Because here it is required some point something ampere current, but here it required some 2 or 3 ampere current. So when they are connected in series, current through them will be the same. So we cannot connect an electric bulb and electric heater in series because its current through the circuit the same, so they cannot work its own power. That is the problem. Another problem when we connect these devices in series is that if any one of them failed to work, then all others does not work. If any one of the gadgets we connected in the circuit in series, then all others will not work. And also each appliance does not get the voltage for its working. That is also another problem. Instead of that, if we connect appliance in parallel, each will get its own potential and current, so its power will be the same. That means for the proper working of the appliance, we should connect appliance in parallel so that the current through each of them will be different, and also the each appliance will get same potential, so they can work its own power. That is the advantage. One more thing we want to remember: if suppose we are connected a number of resistors of same resistance are, suppose n resistors of same resistance are connected in parallel, then its effective resistance in the circuit, then the effective resistance in the circuit, that is Rp is equal to R by N. For example, suppose 10 2 ohm resistors are connected. 10 2 ohm resistors are connected in parallel. Then the effective resistance in the circuit, that is Rp is equal to 2 by 10, that is equal to 0.2 ohm only. That means we can reduce resistance considerably in the circuit if they are connected in parallel. So that we connect household electric appliance in parallel. That is the main advantage. We can reduce resistance and also get same power, and because same voltage is getting for everyone. I hope you like this video. So you share and subscribe this channel. Thank you.